All right, let's go to the second section of the Firenock class. Yes, Aerovane. This is something that most people never understand, and they all got confused. What's so special about Aerovane? That's the second product Firenock ever come up with. It's a vane. But what's the big deal about vane? Well, didn't we all arrows got feathers on it? Or some plastic on it? What's the big deal about vanes? It is not just a vane anymore. Because most people don't understand what vane actually does. In the old days, when you put a vane on an arrow, what is the objective of that vane?
Create drag.
Create drag and
Steering.
Directional. Nothing to do with stability. And how fast are those arrows back then? 120, 85 feet, 100, 150 max. Then we go to about 220 feet per second. Oh wow, this is the best since sliced bread. We got Blazer. And then we got quick spin, didn't we? For a while.
A short while.
Okay, so what does all those, I was like, oh, I would do heavy helical on a Blazer. Do anybody know that 260 feet per second and above, the feathers actually collapse totally? Have no effect, it becomes just blur. You heard the sound. Because feather actually collapse.
After 260 feet per second.
At 300, you just don't even bother until you drop down to that speed, then feather come back up.
I see. Because
feather collapse. Remember, when you put your finger on the feather, they collapse. How much force you need to collapse at? About 280 feet per 60 feet per second. That's your answer. So, what does the vane really do? Well, let me quote Professor Selig's quote. Birds don't fly with feathers. Birds fly with wings. Did bats have feather? Bats don't have feathers. Only birds have feathers. So feather is not, quote unquote, a wing. It's only a structural components. When you have structural components, what are you really dealing with? Flatness. When you have anything that's flat, what does it do when high pressure go through it? It flutters. That means when you have a flat surface and air passing through it, what happens to that surface? How do you overcome this? Have you ever heard a bird fly really loud? Especially like an owl. They don't make any sound when they fly, don't they? Let me just give you a little bit of history. I was in Volleyball State Park, sitting right in front of the travel sign on the one tree that see the entire road coming into it. It was like 4 o'clock in the morning, leaning back, enjoying my morning sun, having come out because 7 o'clock. An owl land right here and stare at me for a long time, and he'd fly back. I said, damn, that's quiet. Why can't my arrow like that? Because back then I happened to use quick spin with an 85 grain broadhead. A full-size quick spin. Let me give you a story. I was hunting in Martinos. My arrow was flying towards the deer. Perfectly. And halfway through it, my arrow go like this and slap the deer sideways. No, I'm not joking. I was like, what have I just visualized? Because I used super light insert and an 85 grain broadhead and a full-size quick spin with the Firenock in it. The arrow literally go like this and go sideways and slap the deer. It tells you how much a drag and wind would do to that arrow. If I had not personally visualized it myself, I would never have believed it. No, seriously, arrow go like this and slap.
Because of the side wind?
That's a drift going across the valley. See, it's like this. I'm shooting from this side towards the deer. Right in the entrance of Martino on the duff field. I was like, something needs to change. And sure, it does. Let me explain to you a little things. When you have this flutter, it gives out vibration. It gives out force. It gives you out disturbance. Let me give you some specs. This is what a normal, an extreme vane that is offset will create. That means when the arrow passes through this space, an 18-inch of circle of air is being disturbed. Remember, we are flying arrow, not at supersonic. We only maximum we got is about 450 feet per second, which is about half the sonic. So whatever that column passed by, that air, when the wind blows by, that column of air is being affected. That means when the arrow passes through the air, the entire column of air is what you're dealing with.
18 inches around it.
Yes. Now let me show you a few more things so you guys can at least get them down. If you base a boat using, say, an offset or helical vane that is well built, we're not talking about using, we haven't included the inconsistent of glue, the inconsistent of accuracy of each vane. We assume everything is perfect 120. We assume the glue is straight on and the helical is right on. Okay? This is what you got normally on an arrow. It's 9-inch.
Backing up real quick, what is a flutter-based vane? What would that be considered? Like a quick spin or a...
Exactly.
Okay.
A quick spin, your spin vanes and so on.
Yep.
We are doing this at 300 feet per second. Okay? This is on a straight flush vane. That means if you are smart enough to today, you don't want to use anything else, you actually get yourself some vane packs and you straight flush it. That's the thing. Because the only thing you're dealing with is flutter only. You're not dealing with other vortices. Pure flutter. This is what an Aerovane 2 gives you. That's our circle of influence. With Aerovane 3, that's the actual number. Now, imagine this. You are now going to stick a pipe into a river. At 8, which is the wind. Wind is like a river. You're going to stick this pipe into the river. You want it to be 18 inch or 1.5 inch if you want the pipe to go straight in. That's your answer. But that's what people is using. Isn't that funny? Sink that in for a little bit. Now, how come such a big deal? Because F-well. You notice that every single, if you look at the Aerovane itself, which I'll give you guys each a few pieces, so at least you got a chance to hold it. So you got to feel what it feels like. Now that's Aerovane 3, and that's Aerovane 2. Now what happened to Aerovane 1? Well, just put it this way, even Professor Saley told me, Dodge, this is too complex of file. I can't even begin to build model with it, so I decided, you know what, it's too complex, too expensive to make, nobody really like it, let's just drop it. Okay, did anybody understand the Bernoulli principle? Okay, this is stating that when a surface passing, if one side have more distance compared to the lower side, the force will from the low side to from the high side to the low side, because there's more travel distance, which means the speed of this air is lower. Since it's less, the speed of this air is faster. By doing so, you end up with resulting lift. That's how airplane flies. And that's the reason when you build a boat, one side is fatter than the other side, the boat will always go with the fatter side. That's the reason the boat is always straight on both ends. It's perfectly even. Otherwise the boat will drift towards one side because of airfoil effect. Technically what we're talking about is the same identical structure of a wing. If you look at an Aerovane, look at it from this side, the side, view it from here. It is exactly a wing. Because if you look at it, this is what the Aerovane should be looked at when you got a pen on the wing. This is what it is. Look at it, the cross section of this is the entire airfoil is right here. See that? See the hump right here in the front? See the lower side? Now just, you notice all the fine line is about the owl. I was very lucky I got a to Professor Lele out of Stanford University. and learned quite a few things from him. The aspect ratio. What do you mean by that? Is how much this curve compared to the entire thing. The more curve in the front, the more round in the front, the closer it is to an owl. That's the reason an owl flies in air with no sound, because this is exactly the aspect ratio of a North American big barn owl. Now, you also notice that on this vane, every single part is thin to thick. You notice that not a single surface is identical in thickness, because we try to prevent fluttering. If you really look at it, this is actually a super thin pyramid. How did pyramid flutter? It can't. That's the reason when you make chisels and everything, they're all triangle based. If it doesn't flutter, you can't make the sound. Now, let's go a little bit further, which explains why the moment you use a linear printable and vortex. Now, this is where a little bit more on science now. You notice Aerovane 3? Technically, Aerovane 2 and Aerovane 3 is the same identical vane. The only difference on structure, the only difference is this bend. Okay? So technically, this should be a little bit smaller, should be right here. What we are really doing is this. It's a winglet. Professor Selig helped me with this winglet. This winglet is based on a newer design. See, this is an old design. The design I have is actually the winglet come in at 90 degrees and offset at 1.5 degrees. Take a look. That wing is not straight. That winglet is curved, like this, upwards. That actually gives you close to 9% efficiency over Aerovane 2. Now, just on Aerovane 2, for the people who understand aerodynamics, it's 70,000 Reynolds. That's how efficient it is. And this is approaching 100. Now, what does that mean? All of a sudden, where it allowed an airfoil to go through air without creating vortex, without having sound, what do you got? And it will turn because it got lift in it. Let me give you some numbers. On a straight vane, like a vane tag, within the first 20 yards, you got about 3 turns. That's the natural capability of the vane. Okay? Or sometimes even none, because it's straight vane. With a 200 degree offset, you may get 8. Aerovane 2, with the testing from, actually, what's his name? Gary Simon Matthew helped me. He told me, Dodge, your vane turned 29 times faster than a Blazer. I said, yeah, that sounds about right.
This is straight?
Yes.
You put these on straight?
Perfectly straight.
Okay.
With absolutely no offset. Now, you say, what happened? Wait a minute. What happened? I should slow. Aha! That's where all the problem and understanding come in. Did airplane ever fly slow? Sure it does. When you take off and land, what do you do? Put the down flag. You notice when you take off the airplane, you're on the plane, you see the plane come up with all the pieces come down. What is it increasing? Down flag. Increasing the size of the vane. That means they make this thing longer and curve like this, so they increase the distance from the top and decrease the distance on the bottom. But increase the ratio of the distance on the top compared to the bottom. So the air going through top even more, which creates even more lift. Because it's landing, there's not enough speed. Now, how do we use this vane to, say, handle 160 feet per second? Now, maybe let me go step back. What is the minimum speed for Aerovane 2 to function? Answer is 270 feet per second. Anything below that, Aerovane 2 won't function as is. That means if you straight fletch it at 270 feet per second or 260 as low, Aerovane do absolutely close to nothing. And that's the reason if you look at the Pearson ball handling result, he told me, every single vane turn, Aerovane didn't turn at all because there's no speed. Just like if you put a Jumbo 747 or a fighter jet down the highway at 45 miles per hour, is it going anywhere? Absolutely not, there's no lift. But then, what happens if we shift the vane this way? Now what we are creating again, we're talking the old method of drag again. Now you're putting drag into the entire system. But at 260 feet per second and 150 feet per second, you need drag because there's no lift. But if you tip up Aero Wing like this, what is the drag? The drag is still there, but it's a quiet drag. It's a quieter drag. It's a more efficient drag. That's what it is. Because if you take a closer look at Aero Wing, on Aero Wing 2, you can, let us step back a little bit. You see the vortex difference? See, the vortex starts from this point instead of this point. That's where the efficiency difference. Just give you a hint. You notice there's no airplane today without this winglet? You can't find one, unless it's OOO plane.
I wouldn't want to be on it.
Not just, you can be on it, that's not a problem. You know the difference? Do you know how expensive airplane fuel is? You can save 5 to 10% of it, minimum 5. Last time I heard, United spent something like $120 million a year on fuel. You know what 5% of that is? It's year after year, non-stop. And that's what the reason when I design Aero Wing 2, I go with Aero Wing 3, I insist on winglet. Because I understand how efficient this system is. And not to mention the crosswind signature is just unreal. Because at this moment, notice that the vortex stop here, come to here, that's the difference. See that, the span? See how big this circle is? See that? It actually comes from here. So that now all of a sudden, your entire crosswind signature jump from 2 inches to 1 1/4. If you look at the ratio-wise, it's a really big jump. It's close to 40% improvement. Now, Aero Wing 2, Aero Wing 3, I jumped myself a little ahead of myself. That's the reason. If you look at Aero Wing 2, and you notice there's colors on it. If you take a closer look, there's a zones. That's where I learned from Professor Sailing. It's called surface texturing. Now, let me start give you a little fun story. When I first designed Aero Wing 1, I paid extra money to polish my mold to get the thing super smooth. When Professor Sailing hold it, he was doing this. I said, George, how come it's so smooth? I said, so you glide through air! He just laughed at me, really. He just laughed at me. He said, you know what golf ball got dimples on it? You know why shark's fin got texture on it? Because the moment you smooth, the entire air grab the thing and without leaving it. Because surface friction like you never believe. I said, oh, that's the reason Aero Wing 1 works so good on traditional bow with an air rest and also on people who shoot broadheads. Because it created so much drag. You actually slow the wing backwards. Now I understand. So, of course, when I learned this, see that's a different texture of the zones. Now, when you look at Aero Wing 3, I learned this even more because I learned this is where the flow of the air behaves, and the most of the flow is at tip. That's precisely this zone right here, actually on the winglet. This zone right here on here, and this zone right here and here, and that is really the minimum. And that's the reason I create the 4th zone on it. And just to comply with the very good company that worked with me, because when I first designed Aero Wing, just learning left and right texturing, I actually accidentally stepped into New Archery Products pattern. And they are because I explained to them what I did. It's my research. This is what comes out. He said, yes, unfortunately, Dodge, this is our pattern. I said, how about this? I make the left and right the same. So you will not be infringed on your pattern. And they very kindly grind me a pattern to sell off all my old products. And now I make the product that do not infringe on the pattern. I mean, that's how the industry should work. Because it's not I'm copying theirs. My research result end up to be what they patent. So I take that very gratefully. You can see how things are. I mean, multiple things can end up with the same result. We'll say the intention, but that's not what I patent. Okay, now let's talk about Aero Wing Jig. Because now you know about Aero Wing. Before we go to Aero Wing, let's talk about some specs. What the industry do not know. Aero Wing 2, if you buy from me, I'll guarantee 0.1 grain variance. That means if you get a pack of 100 from me, they will knock off by 0.1 grain. Aero Wing 3 is 0.07. Okay? Now, normally, nobody ever think about it. Do you know if you use a typical offset, say a blazer or a Vangtech 2-inch, how much weight of glue do you put on it? Anybody knows? Let me give you a hint. It's about 0.8 to 1.5 grain of glue.
1.5 grains.
0.8 to 1.5. Why do you think a typical guy who got to buy a tube of bromine platinum plus only flush 2 dozen arrow and gun? Come on, think about it. That's 2 ounces of glue. Go on 2 dozen arrows. That's 1/72 of an ounce on each vein. Think about it. This is the normal one, isn't it? I mean, we all use bromine platinum plus before. Stick. The tube's gone, 2 dozen arrows. So how much glue you put on it? You see 1 ounce on it, you just on 2 dozen arrows, well, that's half an ounce on each on 12 arrows, so 1/72 of an ounce. An ounce is 700 grain. Now the fun part. If you use my glue, use my jig, it's 0.03 grain per vein.
How do you regulate that though?
It's easy. Because see, the moment you put my clamp on the Aerovane, when you push down, that all the glue comes out. There's only 0.6, that's only at my surface. Because when you put my hand, this is a normal hand, which you put on it, that Aerovane clamp will put 60-pound pressure on the vein. It would just, every single glue will come out. That's the reason 1 bottle of my glue, which I use it, because I use a big airboats, I can do about 60 dozen. That's on the low side, up to 80 dozen a bottle. If anybody use less than that, only mean one thing, they're not careful with it. Because they put more than enough glue, they're not putting pressure on it. Because when you're finished with the Aerovane, this whole feet should be covered and you see glue come on one side, one way or the other. I mean, a huge amount on one side. Because when you push it down, see, the Aerovane itself on the feet, right here. That's a 3mm curve. There's no arrow smaller than 3mm. So the moment you push on it, this thing will spread. And with the force coming down on here, on the clamp, how much glue can be left in it? This is not a flat feet, it's a curved one. So when you push it down, see this side is thicker to thinner. You let it spread out like that. So now, of course, if you look at the good old Bisonberger jig, you are guaranteed no less than 5 degrees off per arrow. You say, wow, 5 degrees a lot. I say, yeah, this is what you do. How you test it. After you finish building the arrow, lay all the arrow flat with the coffin up, walk back 5 feet, look down on the arrows, he'll tell you exactly what happened. Don't have to think my word for it. Bill doesn't, you know the answer. Because see, when you look at an arrow like this, all 3 wings has to be perfect because you're pointing a 3rd one up. If this wing is off, this wing up, you're doing this. If you look at, if you build with Aerovane jig, they all come out perfect. Because when you build Aerovane, you got wing nut on one side, you look at them, they all come out exactly the same. You can't deny it. You lay the arrow on the table and walk back and take a picture. You'll find out exactly what I just said. That's the reason I was forced to build Aerovane jig. Because if you look at all the advertising on 2007, 2008 about Aerovane, we say, oh, use a Bisonberger jigs, use a Jojan. It didn't work. Because remember an Aerovane, that is straight flush on 3 veins. It's a circular lift. Remember the force are straight. The force has to encumber it into a virtual circle. So if you have this one off, this thing will elliptically turn. The vein won't work anymore because you're dealing with lift. That's the reason Aerovane 2, the maximum error is 1.5 degrees, while Aerovane 3 is no more than a degree. 3/4 is more like what it needs to be. Because there's so much power. See, imagine if you do this, just like if you run a motor or propeller, if one of the propeller is slightly off and your speed goes up, that thing will blow up, literally. And the arrow will literally do this. And that's the reason the Aerovane chip becomes such important. But a lot of people use it for production because it's so reliable, so consistent. And with the stainless steel clamp, you can literally push it down. And a lot of people say, unfortunately, like a few of my customers, after 1 year, they send me back the clamp. The clamp is all scratched to beyond belief. I mean, should I say, not you, don't laugh. I see Tim Gillingham's clamp, I literally fall off my chair. I said, what do you do? I just scratch the glue off. I said, no, those are acetone. You put the you put the acetone on the paper towel, and you put the clamp on it, and you put it inside a Ziploc bag. You melt it clean. You now just ruin the two most important part, because when the Aerovane work, it is not this part that you use, it's this part, the point. If the point is not holding together, you are not pushing this down. Because see, when you scratch this part off, it's gone. This is the most important part, is the 90-degree corner. So what I have to do is that I take one of this clamp, I put it back on my grinder, re-grind this thing out until I got this surface right here. I did do that to yours too. But in a much lesser degree. I have to give you credit for that. So you understand why the Aerovane clamp is so critical on that. Now if people say, oh, I need a helical clamp. I mean, let's be blunt. What does word helical means? Wrap around a cylinder, you get a helix. How many arrow sides are there? How many diameter sides are there? You're telling me you have a single helix able to work on from 166 all the way to 27. I would like to see that math. The answer, you couldn't. The only thing you can do is that you put more and more glue, using glue as a mortar to fill the gaps. That's the reason when people start doing the 166, the amount of glue they use when the heavy helical is just beyond imagination, if you have seen it. It's like they literally put about 2 grains of glue per thing, moving it like this way on a 166. You say, oh, it works so good. Yes, you just drag your arrow to the slowest point. You have control. It's like, I can drive an Indy car really good at 45 or 60 miles per hour. Yeah, I try to drive 120 into a corner, you'll be in the war. Same thing. If you slow down enough, everything works much better. But then, you're not really driving it's not the reason to buy all this stuff anymore. I mean, there's tons of customers, literally. Oh, I bought this 350 feet per second bow, and they throw 65 grain of insert into it, and throw 125 grain broadhead, and put a freaking 4-inch feather on the back. Oh, you shoot so good. At 40 yards. You just drop your arrow from say 330 feet per second down to 260, if that much. Of course you shoot good. What would not shoot good? Because you have control over everything. But you're not shooting speed anymore. And yes, you say, well, it kills everything. I say, if that's the case, your old Golden Eagle with the 2219 would do the same. Mm-hmm. There's no difference.
What's the point of having something new if
you're
not using it?
Right, it's like, you know, I can really get a brand new jet plane from here to Peru on Highway 65 at 55 miles per hour. You know what, my Honda Civic can do the same thing too. That pretty much is what they're doing. Mm-hmm. It's using something that's not, I mean, besides having, I have the fastest. It's like having a brand new Lamborghini and delivered milk bottles. You don't need it. I mean, there's no reason to have it. But then, let's look at the entire jig system. Now, a lot of people ask me what's the laser for. The laser is only for production. Because if you do that much arrow like a spine, you don't really want to stand up and look at top and draw down step, look at top. You need to sit down and look with the laser and just draw. It's much easier. Of course, that's a production clamp. Very few people buy from me. That is to retrofit a Bissenberger table using mine. The fact is that, you know, when you use the new glue, the problem is that with all the new glue, that like the AGO 600 that I made, it is only 650 centipoint, which is 0.6% fluidity of water. The moment you put a clamp like that, the moment before you clamp, all the glue come down, there's no glue on top. Now you know why I designed my jig, to make sure that it works horizontally. Because then when you put it down like this, the glue is evenly distributed and gets squeezed out evenly. So when you wipe it, you take out all the issues. Now, have we do any major changes since say 2008? Yes, a few changes changed big time. First of all, the 2-pin of the brass is now stainless steel. Yours is stainless steel. The ball bearing of the water level significantly increased because I designed that. I must also use it. Then I get a long feather adapter, and the most important change is the adjustable hook. That lets you use every single arrow. You know how to change. One will work at all with the water level. So you level this, you're using this to level, this will give you exactly what you need. Now people say, what happened to the adjustable hook? Well, unfortunately, it is no longer available because too many customers are, just say, less careful than I like it to be. So I finally decided, since they are like this, I will stick with my fixed chuck and not go with it. Now if you look at the Aerovane clamp, you notice that 2 ball is not silver but white? Same thing with inside here. All Firenock contact surface is ceramic and the ball bearings are ceramic. That means this clicks will last you about 5 million clicks before it goes. Then you need to buy, see this piece up there? You just need to buy a new piece because as you move, it will eventually wear out the side. So the moment when you feel like there's slop on this piece, you just need to replace this piece for $15. You got a brand new jig. And usually I tell my customer, if you really have that case, send me the jig. I will do a full checkup on you and get you back to production. Because see, until the tool is right, you really cannot build good arrows. Now a lot of people say, what's wrong with using a V-neck, a V groove? Now let me just show you exactly why. Imagine this is your knot going in it. What happened to this? You can't control it. So the only thing you control is shaft to shaft. Because see, every single shaft in the market goes through a mandrel process. Do you know what a mandrel is? That means you wrap the fiber over it. So that there's an absolute guarantee the ID is the same. So the moment you put a chuck in it, now the chuck and the shaft become one. You have control. You do know this every time when you put your arrow into the Aerovane jig, you can take the whole jig up from the arrow. That's how good a connection is. Until the arrow and the jig become one, you have no control over the thing. Which is why a lot of people use a knot, or even worse, some people use an old Mako knot on a Bissenberger. You notice when you turn the knot, the arrow actually flipped on the third one. Now you know why a Bissenberger index is not 120, 120, 120, but 120, 120, 118, and 122. Because you want to compensate for that drop on the 2290 with a Mako. So if you precisely hold the arrow on every single one of them, you just added 4 degrees to it. And of course, this is our 3 and 7 index. Now say, why do we need 3 or 7 index? What's the 7? The 3 of course is 120, 0, and 240. The 7 index is your 0, 60, 90, 120, 180, 240, and 270.
Ours are 7, aren't they?
Right, the reason for that, because now you can do 4 vanes and also do the bow tie. You start with a bow tie with a 0. So if you want to do the Tech 15, you index the arrow at 120 degree. And you start with 0, 0, 80, all the way 180, 240. That'll give you the PSC bow tie. Or you can do the 6 vane, which I do not see anybody doing it. Now people say, what's the big deal about the 4 vane compared to 3 vanes? 3 vanes are always better, unless you're not good at fletching. But the fletching is not effective. Because see, the moment, think about it, the moment when the arrow turns at one moment, if the wing is coming in with a 4 vane, you have 2 position, that's 100% hit. But the vane is at this position, it's 100% hit. Why the 3 vane is always even? Because when the vane is like this, it's the lowest on the 90 degree. That's the lowest position. It's the worst position. With the 160, that's no difference. Because always maintained. That's the reason the 3 vane is always better than the 4 vane, unless you need more drag. But this system is not based on drag, based on lift. Why do you need more drag? You have no control over the front of your arrows? Or some people have really bad broadheads. Now you need drag because you have no control of the broadhead. And finally, of course, the long feather adapter. See, for some people who like to use the old feathers and still want to use the Firenock Aerovane jig, we'll let you put the long feather adapters and of course the water level. Now, good cyanide acrylite. What's the big deal about this? Why is it so many people have a problem with it?
The problem I have is sticking my fingers together.
Right, besides that, cyanide acrylite will attack water very seriously, and your finger have moisture on it. I mean, just like the old days, if people want to lift fingerprints, they use cyanide, they use super glue, the super fluid, like they film it. Now, let me go back a little bit since we're talking this subject. Now, if you got a customer, you have to put your Firenock together for them to go. They say they want the Firenock in front of them installed. Now, you just glue the Firenock end cap in it, right? If you go ahead and put the battery and Firenock into the Aero and say you don't shoot until tomorrow, do you know what's going to happen? The Firenock is not going to work.
The fumes?
The film of it will cover the battery and the wire. How do you overcome it?
Wait.
If you have to do it, go ahead and get a small tape and tape over the battery and the wire together. You can plug it in. Because it prevented the thing from depositing onto it. So you have to do it, that's the way. But if you do that, I will tell you that's not ideal. Because remember, the super glue is not gel dry yet. You're going to deposit the powder all the way through the shaft because it's not open on both ends. So always do the shaft possible with the nut end on, also at the point end off, so the air can go on both sides. The more moisture you come in, don't drop water in it. It's not a good idea. You need natural 60% to 70% moisture for the super glue to dry with the end cap. I don't want to go to chemistry or explain to you why this molecule will work with air, but that's the chemistry deal.
What's the time frame then? What's the ideal?
The ideal is the ideal is 76 degrees. At 76 degrees, about 70% moisture. That's the reason a lot of people have problem with this glue at lower temperature. Lower temperature is not right because it will cause the crystallization to too fast. It become brittle. And it also start pulling oil from the vein, will cause it to crack in cold weather. That's the reason when you do a super low moisture environment, when you put the Aerovane together, like winter time, and you shoot in cold weather, the vein will crack right underneath the line. Because you're putting all the moisture off the vein. So when you shoot in cold weather, when the plastic gets brittle, it just cracks right there. Because that's the weakest point. I mean, the Battle Creek out of Canada, which of course a lot colder, a lot drier than us, he actually keep his off at 75 degrees with 70 to 80% moisture. So he can flush this thing right. Now what is the big deal about cyanide acrylite and about AGO 600? This is a cyanide acrylite, the 650 centipoid, but with no preservative. That's the big deal. You have no stabilizer, no preservative in it. When you buy anything in the market, when is it being made? Remember, all the glue are like milk. The moment you mix it, the moment you come out of it, that is degraded. You can slow it down, but when you slow it down, you also give up something. Just like you got a can of powdered milk and you fresh milk off the cow. What's the difference? Taste, nutrients, all the rest of the goodies that you wanted. So if you're able to extend something with life, you have to give up something. That is no free deal. If anybody tell you, they just don't live long enough. Now, why do I make 3 bottles? Remember I showed you all the Firenock come with 3 bottles? It's called the dip, rinse, and flush. You dip the Aero into the first bottle, mark it dip. That's to clean the first junk. Then you go into rinse. Then you do just in case whatever dirty here, you rinse it, you dilute it. And then finally you clean your vein with your Q-tip with a small bottle on the back and then wipe it same direction. Don't go like this and this. Because when you wipe the acetone, you feel acetone and you go the same direction, you lift all the oils off it. Now that's where the problem is. On super dry area, when you do that and you take the moisture out, you literally crack the vein. That's where moisture control is important. But then, at the same time, when you like last time I was doing a vein job in Georgia, when the moisture is 100%, the veins don't stick. Too much moisture. That's not enough time. It's too fast. So that's control over everything. But then, at the same time, how many glue you know? A tiny bottle like this will actually do 60 to 80,000. I mean, you guys do enough. I don't have to tell you. It actually is the case, unless the guy just wastes. I mean, like good old friend down in Wolf Hollow, he freaking do 10,000 arrows, that AGO 600 is finished. How? I don't know. If you look at my bottle, I just did about 8 dozen arrow with that. I still have that much left. Okay. Any question on Aerovanes?
Those 3 bottles that you had up there, go back to just one.
Mm-hmm.
On the top left.
Mm-hmm.
Now, what is that for?
Rinse, dip, rinse, and flush.
So you no longer use the Q-tips.
Oh, Q-tip with this. You first of all, when you got an arrow, prep the arrow first.
Right.
Most arrows come out. You got carbon dust. You got hand oil on it. You dip in the first one, come out. You wipe it once. Is that arrow clean? Answer is no, because whatever is in this bottle, it still have residual on it. Then you do a fresh rinse. This method is used in every single restaurant. Remember, in restaurant you got 3 tank cleaning for bowls. The first one with detergent, you rinse the bowl. You come out, you do a clean rinse. Then you do a final. You need three piece. That's usually 3 piece. This is always clean. So what happens is that this bottle can go to this bottle, this bottle go to this bottle, this all will come with fresh ones. That's how you rotate them. When this is get too dirty and dark, when you put an arrow into it coming out and you got all the white film on it, this is used up. You pour it down the drain. Because it's acetone, it's not dangerous. So you pour this into this, and you pour this into this. It's a rotation.
I see.
You always have fresh in this.
Yep.
Because you will not believe how dirty each arrow is. I mean, Black Eagle gold tips are famous for being beyond dirty. When you come in, you see the dust settles. And of course, if you glue end caps, then in Firenock, you know, if you don't clean the inside shaft, that end cap ain't gonna stick. You might as well just ready to give the guy a new circuit and new battery.
Going back to the jigs,
Mm-hmm.
is the arrow, how crucial, no, go forward, the one you just had there, how crucial is that to have your arrow level?
Very. The more level it is, the better the adhesion. Because now the glue is moving. Remember, we're talking 650 centipoint. That fluid is moving very fast. The moment you tilt it or like this, the more you push down on it, if you do this and you push down, you notice more glue here and less glue here.
Okay.
Because when you do, a lot of people using this piece right here, they find out it don't work right.
Because it's...
Correct. People say, I put more glue on top. I said, yes, you can do anything if you got the skill and know-how. Okay? I have seen history. Some guy with a chopping knife is the best surgeon. But how many people can do it? Not me. Okay? Don't tell me some people with extreme skill can do anything. Some people can run rope, walk a rope through Grand Canyon. Forget it. Not this guy. Just because somebody can do it do not help you. What we are promoting is that we want to give to anybody with the training and know-how, instantly able to do it.
Consistency.
Correct. So that means you have this skill, you teach the next person, they have the same skill set because the tool is the same. Because if you rely on somebody with a super skill so like artist, you can't pay them enough. And when they leave, you don't have no more people to work. That's the problem in most shops. Unless the shop owner owns everything, do everything. Yes. But what happens if he is busy, what other people do, you need to train and get the same result. That's how you run the shop. Because nobody can really run arrows on just from September 15 to October 15. It's crazy. You don't have enough time. That's the reason I designed Aerovane jigs so that you have 2 jigs in front of you. You are a fletching station. Yes, you do need that. You do need at least 1 bottle. Because somebody can clean all of them. To say I got ultrasound system. I clean all my arrows, 200-300 at a time, and then go in here. But then I do pay $5,000 for my ultrasound system.
We'll take 2.
Yeah, but you know, instead of doing 1 by 1, I can do 40, 50 at the same time. But then you're looking at ultra system with ventilation, the whole deal. You can see those machines are there for that exact reason. Because when you build a few thousand arrow ball like me at a time, you gotta admit it. Otherwise, the stuff don't come out right. Just like doing anything else. If you don't prep it, it's not gonna come out right. When a few will come out right, you don't have your consistency, you don't have your accuracy. Did I answer your question?
Yep.
Good. Any other questions? Good. So under that condition, it will conclude our second sessions.